Okay, so hi everyone. In this video, we are going to discuss about step-by-step solutions to find recurrent solutions. So these are the four main steps. So first is finding the order or degree of the recurrent solution, and then finding the characteristic equation, then finding the roots, and finding the constants. So um, first is finding the order or degree of the recurrent solution. So when we say the degree of a recurrent solution, so it is the largest of the previous terms that are used to define the current terms. So for example, if we have f of n equals f of n minus 1 plus f of n minus 2. So in order for us to get this f of n, we need to compute for n minus 2 and f of n minus 1 and f of n minus 2. So we need to we are using the two previous terms, f of n minus 1 with f of n minus 2. So we can say that its degree k is equal to 2. Alright. So now is the next step would be finding the characteristic equation. So to find a closed form solution or expression for the sequence, we need to find a characteristic equation that relates the current term to the previous terms. So in this case, if we have a recurrence relation that is a sub n, so let me just use RR. Let me just use say RR for recurrence relation. So if we have recurrence relation a sub n equals c sub 1 times a sub n minus 1 plus c sub 2 times a sub n minus 2 until c sub k times a sub n minus k. Okay, so we can see that this a sub n, oops, this a sub n is defined by its previous term a sub n minus 1, a sub n minus 2, and a sub n minus k. Okay. And the basic approach for solving this recurrence relation is to look for the solutions of the form a sub n equals to r raised to n. Okay, where r is constant. Okay, so if we have this recurrence relation, then the characteristic equation would be r raised to n equals c sub 1 times r c sub 1 times r raised to n minus 1 plus c sub 2 times r raised to n minus 2 until c sub k times r raised to n minus 2. So notice that what we did was to simply replace the a with the r, since we mentioned that a sub n is equal to r raised to n. Okay, so now what we simply do is to transpose all of these terms to the other side, all of the terms on the right to the other side. So we will be having r sub n minus r sub 1 times r raised to n minus 1 minus c sub 2 times r raised to n minus 2 minus and here c sub 3 times r raised to n minus 3 and that will be equal to 0. Okay, so we have this final characteristic equation. Okay, so after that, then we are going to find the roots of this characteristic equation. So let us find that. So the solutions to this characteristic equation with single time is what we call the characteristic index. Okay? So if there are two distinct index, it is generally solution. So note that these are, so the van Waalen characteristic equation before. So this is the r sub n minus c sub 1 times r sub n plus 1. Now, unknown yung mga r's. Ano yung mga r's? So, ano yung mga distinct na roots dito? So, we will have, that's our problem. Is to find the roots of this equation. Where r's are can be trivial number or complex number. Can be a real number to a complex number. So after now is we are going to find the constant. Okay, so yung constants na naman natin dito, yun ay yung roots or the characteristic equation as well as alpha 1 and alpha 2. So saan ba nang galing itong si alpha 1 and si alpha 2? Okay, so we will discuss that after this. So assume naman meron tayong recurrence relation RR, which is a sub n equals c sub 1 times a sub n minus 1 plus c sub 2 times a sub n minus 2. Okay? So now, ito yung recurrence relation natin. Now, balik tayo sa first na, first na step. That is finding the order or degree of the recurrence relation. So what is the degree? It is equal to 2. Because this a sub n is defined by its two previous terms, a sub n minus 1 and a sub n minus 2. Okay, so next is what would be the characteristic equation? This CE is characteristic equation. So we said that finding the characteristic means in finding the characteristic equation, we use the form a sub n equals r raised to n. Okay, so what we do is to simply replace a with r. So we will have r sub n equals r sub 1 times r. Sorry. So this should be c sub 1 should be r raised to n equals c sub 1 times r raised to n minus 1 plus c sub 2 times r raised to n minus 2. So notice na ni-replace na natin yung a sub n with r raised to n and is a sub n minus 1 with r raised to n minus 1 and a sub n minus 2 with r raised to n minus 2. Okay, so what we'll do next is we are going to transpose these terms to the other side, these terms to the other side. So we will have r raised to n minus c sub 1 times r raised to n minus 1 plus, sorry, it should be minus c sub 2 times r raised to n minus 2 equals 0. Okay? And we are going to simplify this by dividing this whole equation by the smallest degree or smallest equal, which is n minus 2. So we will then have this characteristic equation divided by r raised to minus 2. Okay, so now it will give us r raised to n minus n minus 2 minus c sub 1 times r raised to n minus 1 minus n minus 2 minus c sub 2 times r raised to n minus 2 minus n minus 2 and equate the whole equation with 0. So then this will be simplified to r squared minus c sub 1 r minus c sub 2. So we can see that this r raised to n minus 2 minus n minus 2 will be r raised to 0, which will equate to 1. Okay, so now this is our characteristic equation. So we are done with the step 2. So we are done finding the b and then finding the characteristic equation. Now our step is finding the roots. So how do we find the roots of this characteristic equation? So what our problem would be to find the two distinct roots, r sub 0 or r sub 1 or r sub 1. Okay, so this one has two distinct definitions to follow. So this one will have again so two distinct roots, r sub 1 and r sub 2. So applying the current solution, characteristic equation, and here is the roots. Now after finding the roots, it's we need to find the function. So we have a given wherein say we have two constants, let c sub 1 and c sub 2 real numbers. If we have this characteristic equation, r squared minus c sub 1r minus c sub 2 equals 0, which has two distinct roots, r sub 1 and r sub 2, then the sequence is recurring solution a sub n equals c sub 1 times c sub n minus 1 plus c sub 2 times n minus 2. So that can just be like that. So we have the r n a sub n and c sub 1 times r a times sub n minus 1 and c sub 2 times a sub n minus 2. Then the solution or the closed form solution would be a sub n equals alpha 1 r1 plus alpha, alpha 1 r sub 1 raised to n plus alpha 2 r sub 2 raised to n. Diba yung problem natin kanina is maghanap ng closed form solution equal sa recurrent solution. Okay, so if ito yung solution natin, ito naman yung closed form solution. Okay, so ito yung solution natin. So yung general solution is closed form solution. Closed form solution of the recurrence solution. And that involves first, again, that involves first determining the degree, and then getting the characteristic equation. And after finding the characteristic equation, then we can find the roots of the characteristic equation, r sub 1 and r sub 2. And by theorem 1, so we have this first form solution e sub n equals alpha 1 r1 raised to n plus alpha 2 r2 raised to n. Okay, so Yung R na ito is 2 R's, R sub 1 and R sub 2 are the roots. These are the roots of the characteristic equation that we have found. Now, the problem we are having is to find out or to compute for the constants, which is the alpha 1 and the alpha 2. And it is indicated here. Finding constant. So yung hahanapin natin ay yung alpha 1 and then yung alpha 2. So yung derivation is yung step-by-step na solution, finding yung solution. So in the next video, we are going to have an example. So we will be